Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. Right. In this video, we discuss some questions from group theory that have appeared in IIT JAM examination held in 2025. And regarding group theory, I have made two videos separately, and this is the part 1 of the two videos. And these questions are suggested for the aspirants of CSIR NET and all set examinations of different states. Right. This is the question number 9 for 1 mark. The given question is, let G be a finite abelian group of order 10. Okay. Let X naught be an element of order 2 in G. Let capital X is the set of all X belongs to G such that X cube is equal to X naught. Then which one of the following is true? We are given 4 options. In these 4 options, how many elements are there in X is asked. Option 1, X has exactly 1 element. Option 2, X has exactly 2 elements. Option 3, X has exactly 3 elements. Option 4, X is an empty set. Right. Let's now discuss the solution of the problem in detail. We are given a finite abelian group G, underline abelian, and its order is 10, which is written as the product of 2 primes, 2 into 5. Now let us recall a famous fundamental theorem for finite abelian groups. It states that every finite abelian group G of order PQ, where P and Q are distinct primes, is isomorphic to a direct product of cyclic groups of the form ZP cross ZQ. Right. Using this theorem, G is isomorphic to Z2 cross Z5. Further, Z2 cross Z5 is isomorphic to Z10 because the GCD of 2 and 5 is 1. We have such a result. ZP cross ZQ is isomorphic to ZPQ, where PQ are prime numbers, distinct prime numbers, and the GCD of P comma Q is equal to 1. Then this happens. Right. G is isomorphic to Z2 cross Z5 and Z2 cross Z5 is isomorphic to Z10. Therefore, G is isomorphic to Z10. What is Z10? A cyclic group of order 10, and thereby G is a cyclic group of order 10. Right. And we take G is equal to Z10 itself. What is Z10? It consisting of 0, 1, 2 up to 9. These are the elements of Z10 under addition modulo 10. Agreed. We continue in the next slide. Right. This is what we have done so far. Let us take capital X. Given X naught belongs to G. And it's also given order of X naught is 2. So, in Z10, what are those elements whose order is 2? Whose order is 2? Order is 2 in Z10 means what? If X is an element, order of X0 is 2 means X0 plus X0 modulo 10 is equal to 0. That's the question. So, is 1 plus 1 is 2, modulo 10 is 2, is it 0? No. Suppose we take 5, 5 plus 5, 10, modulo 10 is 0, yes. So, the order of X0 is equal to 2 will imply X0 is equal to 5 and there is only one such element. You can check. Right. Now, we have capital X is equal to the set of all X belongs to G such that X cube is equal to X0. That is equal to the set of all X belongs to G. What is X cube? X plus X plus X modulo 10. Because we are working under addition modulo 10. Cube means X cube means X plus X under addition modulo 10. That is 3X is X0 is 5. 3X is equal to 5 modulo 10. That is 3X is congruent to 5 modulo 10. That is the set of all X belongs to G such that 10 divides 3X minus 5. Use the definition of the congruence. So now get into Z10 and what are those elements which satisfy this one? 10 divides 3X minus 5. Suppose you take X is equal to 0. 3X divides minus 5. What is minus 5? Is plus 5. 10 divides 5. It is not true. Take 1. So 10 divides 3 into 1. 3 minus 5 is minus 2. 8. So 10 divides 8. This is not true. Like that you go on verifying this one. There is only one element that satisfies this one. Suppose you take X is equal to 5. 10 divides 3 into 5. 15 minus 5. 10. 10 divides 10. So it is only one element, that is 5, which satisfies 10 divides 3x minus 5. That means which satisfies X cube is equal to X0. So X consisting of just only one element. It is a singleton set. Therefore, X has exactly one element. Now call on the options. So our answer X has exactly one element appears against option 1. Therefore, the answer to this question and option 1 is true and the answer to this question is option 1. That is the detailed discussion of the solution of this problem. And you see, practicing some of the questions given in some of the competitive examinations like IIT JAM will help you, will help especially our CSIR net aspirants. Why? So you can learn and learn some of the techniques from there and you can implement it in your examination. That will be helpful. I suggest for each one of the serious aspirants, you go through some of the questions that have appeared in JAM examination. Right. We move on to next question. Question number 13. It is an MCQ for 2 marks. The given question is, let capital X is equal to the set consisting of X belongs to S4, X cube is equal to identity. And Y is the set of all X belongs to S4 such that X square is not identity. If M and N denote the number of elements in X and Y respectively, then which one of the following is true? We are given 4 options. Option 1, M is even and N is even. Option 2, M is odd and N is even. Option 3, M is even and N is odd. Option 4, M is odd and N is odd. Right. Let's now discuss the solution of the problem in detail. We first take capital X. Given capital X is equal to the set of all x belongs to S4, the symmetric group on 4 symbols, such that x cube is equal to identity. And order of x is m. Is m even or odd? That's the question. Right. Now, x cube is equal to identity means order of x divides 3. When order of x divides 3, what can be the order of x? It may be 1 or 3. Suppose you take order of x is equal to 1. Who is that element? X. Whose order is 1? This implies x is equal to E. Only one element. Order of x is equal to 3 in S4 means who are the elements in S4 whose order is 3? It is a 3 cycle. So x is a 3 cycle. The question is, how many such 3 cycles are there in S4? Right, that is the question. So we have a formula, that is the number of R cycles in Sn is given by NCR multiplied by R minus 1 factorial. So we want 3 cycles in S4. So it will be 4C3 multiplied by 3 minus 1 factorial. The number of 3 cycles in S4 is 4C3 into 3 minus 1 factorial, and when you compute, it is 8. And while we are studying S4, our teachers will tell us, what are the elements of S4, all the 24 elements of S4 we write, and how many elements are there of order 2, of order 3, of order 4, and so on and so forth, they teach us. And that will be helpful. Right. Now, m is equal to the order of x is 1, that is x is equal to E. Number of 3 cycles are 8. 1 plus 8 is 9, which is odd. So, options 1 and 3 are not true because in which m is even in both the cases. Therefore, from options 2 and 4, what is true? So, you have to go for n. Now, given capital Y is the set of all x belongs to S4 such that x square is not identity, and let order of y be n. Now, x square is not equal to identity means order of x is not 1, order of x is not 2. Therefore, the order of x is greater than or equal to 3. So, when order of x is greater than 3, x belongs to S4, what it can happen? Order of x can be 3 because all 3 cycles are there. Order of x can be 4 because we have 4 cycles in S4. And suppose you take order of x is equal to 5. This is not possible because we have only 4 symbols. Order of x is equal to 6. If you take order of x is 6, you must have a permutation in S4 whose disjoint cycle representation. In that, do we have 2 disjoint cycles of length 2 and 3? No. If you want to have 2 disjoint cycles of length 2 and 3, you need to have 5 symbols. But we have only 4 symbols. So, order of x is not 6. So on and so forth. So, order of x is 3 or 4 only, which is a good observation. Now, order of x is equal to 3. Who are the elements whose order is 3? There are 3 cycles. How many 3 cycles are there? We have already seen in the first case. There are 8. The number of 3 cycles in S4 is 8. We have already computed here. And order of x is equal to 4, means x is a 4 cycle. How many 4 cycles are there? Use this formula. So, the number of 4 cycles in S4 is 4C4 into 4 minus 1 factorial. That is 3 factorial, that is 6. Now 6 means, 6 here, 4 cycles, 3 cycles are there, 8. In total, 8 plus 6, 14. So the n is equal to order of y is 8 plus 6, that is 14 is even. Thus, m is odd and n is even, that is option 2. So the answer to this question is option 2. That is the detailed discussion of the solution of this problem. This problem tells you, for all of our aspirants of all the examinations, I am telling you, that you must have a very good command on symmetric groups like S3, S4. So you limit up to S4 and S3 and S4 and study them. What are the elements? What are their properties? And how many cycles are there? How many elements of a given order is there? So on and so forth. You must have a very good command on S3 and S4. So, my dear students, please prepare a good notes on S3 and S4 and study their properties. Right. We move on to the next question. The next question is the last question in this video. This is given question number 59 for 2 marks. It is NAT, means numerical answer type. That means numerical answer you will get. That you have to keep it. The given question is, let G be an abelian group of order 35. Let M denote the number of elements of order 5 in G. And let N be denote the number of elements of order 7 in G. Then the value of M plus N is equal to. So we are given a finite abelian group G. Order of G is 35. 35 is 5 into 7, where 5 and 7 are distinct primes. Again, we use the fundamental theorem of finite abelian groups. Then G is isomorphic to Z5 cross Z7. But 5 and 7 are distinct primes and their GCD is 1. Therefore, Z5 cross Z7 is isomorphic to Z7 into 5, that is 35. Z35, which is a cyclic group. Z5 cross Z7 is isomorphic to Z35 because the GCD of 5 and 7 is 1. Z35 is a cyclic group. So it's a cyclic group. So therefore, you can take G as Z35 as a cyclic group of order 35. In a cyclic group, if you have a positive divisor D that belongs to the order of the G, then the number of elements in G of order D are given by phi of D, where phi is an Euler's phi function. So this is the result. If D is a positive divisor of N, where N is the order of the group, the number of elements of order D in a cyclic group of order D of a cyclic group of order N, right, is phi of D. So it is 35. It is 35. So 5 divides 35. 7 divides 35. So the number of elements of order 5 and 7 are given by phi of 5 and phi of 7. Now 5 divides order of G. 7 divides order of G. The number of elements of orders 5 and 7 are phi of 5 and phi of 7 respectively, where phi is an Euler's phi function. What is phi of 5? Phi of any prime number p is p minus 1. So m is equal to phi of 5, that is 5 minus 1, 4. N is equal to phi of 7, that is 7 minus 1, 6. So the total, what is wanted, m plus n is equal to 4 plus 6 is equal to 10. The answer to this question is 10. Right. That is the numerical answer type question. Right. And your observation in these questions is you need to remember what is the fundamental theorem for finite abelian groups. You need to remember in a cyclic group of order n, if D is a divisor of n, how many elements of order D are there? That's the formula. So the different formulas what I have suggested, what I have used, you note down in your notebook, and the properties of S3, S4, the number of elements, number of 3 cycles, how many are there, how many different permutations have different properties, and all those are very important. You prepare a good notes and that will be helpful to you. With these few words, I say, I am sure that you have understood the solution of this problem. And thank you for watching this video. Now, please like my videos and share with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I hope to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.